Okay, this is 3.6a of algebra. So a compound inequality is when we stick two of our regular inequalities that we've worked with so far, and we put them together. So if you look over here, we put two of them together and we get one like segment here. There's a certain number that we can choose from. Whereas over here, when I stick it together, I've got, it kind of looks like it's just two different ones just on the same line. So the one on the left, we're using and. X needs to be greater than or equal to 3, and it needs to be smaller than or equal to 7. Whereas over here, x is less than -2, or x is greater than or equal to 1. So we've got and compound inequalities and or compound inequalities. Okay, so this is graphing here. So we need to come up with our inequality and then we need to graph it. So let's just look down at our got it problem. So A, all real numbers that are greater than or equal to -4. I'm going to stop right there. That's one of the things I need to write out. So I'm going to use x. X is greater than or equal to -4. And then my other one is that x is less than 6. So if I first just graph my x is greater than or equal to -4. So at -4, I'm going to have a closed circle. I'm going to try plugging in -3. -3 is greater than or equal to -4. I would rather owe someone $3 than owe them $4. So this is true. So I need to draw my arrow going this way. Okay, now I'm going to graph my x is less than 6. So if I plug in 7, I get 7 is less than 6. That's false, so I need to go towards 5, and I have an open circle. So now when I combine these, I've got an open circle at 6, closed circle at -4, and I connect them in between here. I'll do this in a color. So open circle at 6, over here at -4, I've got a closed circle, and I connect them. I'm overlapping them and sticking them on top of each other, because this guy goes on forever this way, and this one goes on forever this way. So when I overlap them and I need to make both of those true, I keep both of my endpoints and I just have that middle chunk. Now over here, let's try doing the other one. So B, okay, all real numbers that are less than or equal to 2.5. So x is less than or equal to, and I'm going to change that to be 2.5. Or greater than 6. So x is greater than 6. So I'm going to graph my first one. Let's move it over here a little bit. 2.5 is going to be between 2 and 3. And it's going to be a closed circle there. X is less than, so if I plug in 2, 2 is less than or equal to 2.5. That's true, so we're going this direction. Then if I graph x is greater than 6, so if I plug in 7, I get 7 is greater than 6. That's true. This is an open circle and going towards 7. So then when I overlap them, or when I stick them onto their same graph, they don't actually overlap. So this is one of my OR ones. So they just look like they're two different graphs just sharing a number line. And that right there would be my answer. Okay, solving a compound inequality involving and. So this is what one of those might look like up here. I don't really like the way they did it. They mentioned you could do it a different way, so we're going to try that. So I'll just explain it down here in our got it problem. So -2 less than 3. Okay, so my goal is to get y alone. So if you look at this middle stuff here, I need to change that to get y alone. So ignore the two things on the side. If I just had that and was trying to get y alone, you'd tell me the first thing I should do is I should add 4. So I am going to add 4, but now I need to add 4 to all 3 spots. So let me draw on lines here. Now I've got 3 different columns that I need to be adding things to. So if I add 4 over here, I get 2. This would just leave me with 3y. And over here I'd get 18. So now if I'm trying to get y alone, I need to divide by 3. So I need to divide by 3 to each of these. Over here I'm just going to leave it as a fraction, 2/3. This 3's cancels out and that just gives me y. And over here I get 6. So this would be my answer. 2/3 is less than y, which is less than 6. If I want to see what that looks like in 2 different things, that's 2/3 is less than y, and y is less than 6. And then I'm going to graph that on one graph. Another way, you really don't necessarily have to graph it in 2 different chunks. I don't have to graph this and then stick them together. I can just do this all in one number line. So if I put 2/3 here, because when I'm working with and inequalities, if I know it is an and inequality, and it'll look like this where they're up here where they're all connected, right? They're all in one chunk. I know both of these are open circles, and then I'll connect them in the middle, because y needs to be between them. So that's where my line is. You could graph it like we did in the first one where we graphed it 2 separately and then stuck them on the same graph. That would also work. Okay, to earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusively, which means if you have an 84, you have a B. If you have an 86, you have a B. That's what inclusively means. You score 86, 85, and 80 on the first 3 tests of the grading period. What possible score can you earn on the 4th and final test to earn a B in the course? Okay, so before we get into the inequality stuff, let's talk about averaging. So when I average something, I add them up and divide by the number of things that I'm adding. So if I wanted to find the average of these 3 test scores, I would do 86 plus 85 plus 80 and divide it by 3. Okay, but now we're adding an extra one. I'm adding in a test I don't know the score of yet. So that's where our variable is going to come in. So it's going to be 86 plus 85 plus 80 plus x, whatever the new score is. And then how many things do I have there? I have 4 things. So I would divide by 4. The lowest I want that to be is 84. Right? If I want that B, the lowest this possibly can be is 84. And the highest to stay within a B would be an 86. So that's where this inequality comes from. I stuck the averaging stuff in the middle, and then I said the lowest I wanted it to be was 84, the highest I wanted it to be was 86. And then we would solve it. So let's try it on our own down here because we've got the exact same situation. Okay, so this time you scored a 78, 78, and 79 on the first 3 tests. And we want to know, is it possible to earn a B in the course? So first I'm going to work with that averaging thing. So 78 plus 78 plus 79 plus x. And I'm adding up 4 things, so I'm dividing by 4. Again, the smallest it can be is an 84. The biggest it can be is an 86. Okay, the first thing I'm going to do is I'm going to simplify the stuff on the top there. So 78 plus 79 is 235. So first thing I need to do is I need to multiply by 4. And remember, I need to do this to all 3 columns. So if I multiply by 4 over here, multiply by 4 over here, multiply by 4 over here, 84 times 4 is 336. That just gets rid of the 4. 4's cancel out, so I'm left with 235 plus x. And 86 times 4 gives me 344. Okay, so now I'm trying to get x alone again. So I need to subtract 235 from all 3 columns. 336 minus 235 is 101. I get x alone there. And 344 minus 235 gives me, 344 minus 235, 109. So, they said that the highest I could get on a test was 100, so it is not possible to get a B, because in order to get a B, I need to get between 101 to 109 on that test, which is not possible. So it's not possible to get a B. Not possible. And the German